Imagine dropping the entire Earth into a bathtub. Now imagine that bathtub is so large it could hold 1,300 Earths. That's Jupiter, a world so massive, so gravitationally dominant that it doesn't just orbit the Sun. It reshapes everything around it, pulls things in, tears things apart. And in the early days of our solar system, it may have devoured entire planets that no longer exist. The question isn't whether Jupiter is dangerous, it's whether we'd even be here without it. Jupiter contains more mass than all the other planets combined, more than twice as much. Its diameter is roughly 140,000 kilometers. You could line up 11 Earths side by side, and they barely stretch across it. But size alone doesn't capture it. What makes Jupiter truly terrifying is gravity. Its pull warps the trajectories of everything in the solar system: asteroids, comets, even the orbits of other planets. Think of it as the silent architect of our cosmic neighborhood. And here's where it starts to get unsettling. Jupiter doesn't have a solid surface. There is no ground. If you tried to land on it, you wouldn't crash, you'd sink. The planet is a swirling mass of hydrogen and helium that gets denser and hotter the deeper you go. At the cloud tops, temperatures hover around -145 degrees Celsius. Descend a few thousand kilometers, and the gas compresses into liquid metallic hydrogen, a form of matter so exotic it barely exists anywhere else in the known universe. Deeper still, pressures reach millions of times Earth's atmospheric pressure. Temperatures soar past 20,000 degrees, and somewhere at the core, conditions may rival the surface of the Sun. Nothing survives this descent. Nothing. And before you even reach that abyss, Jupiter tries to kill you another way. The Great Red Spot is a storm that has been raging for at least 350 years. Earth could fit inside it. Wind speeds exceed 400 kilometers per hour. Jupiter's atmosphere is laced with jet streams moving in opposite directions, generating shear zones where smaller storms are born and devoured in cycles that never end. Lightning bolts discharge with energies thousands of times greater than on Earth. The storms aren't seasonal, they don't pass. This is permanent turbulence. But Jupiter's destructive power isn't limited to what falls into it. Its gravity reaches outward millions of kilometers. To understand how ruthless that influence can be, we need to go back 4.6 billion years. The early solar system was chaos. Dozens of protoplanets were forming in a disk of gas and dust around the young sun. Jupiter formed first. Because it formed beyond the frost line, where ice could condense, it had access to vastly more building material. It grew fast. Within perhaps 3 to 5 million years, it began pulling in gas directly from the surrounding disk. Once that runaway process started, it became a gravitational monster almost overnight on cosmic timescales. And this is where things get dark. A hypothesis known as the Grand Tack suggests Jupiter migrated inward toward the Sun before Saturn pulled it back outward. During this migration, anything in its path would have been scattered, flung into the Sun, or ejected entirely. Think about that. There may have been planets between Mars and Jupiter that simply no longer exist. Worlds that were forming, accumulating atmospheres, developing the potential for something, until Jupiter swept through and erased them. Some models suggest an entire generation of inner planets was destroyed, and that Mercury, Venus, Earth, and Mars are the second generation. Replacements formed from leftover debris. We can't confirm this with certainty, but the models are compelling. Jupiter may have devoured worlds, but here's the catch. That same destructive force may be the reason we're alive. Jupiter's gravity acts as a cosmic shield. In 1994, we watched it work in real time. Comet Shoemaker-Levy 9, roughly 2 kilometers across, was captured by Jupiter. If that comet had hit Earth instead, it would have been an extinction-level event, no question. And it wasn't a one-time occurrence. Jupiter gets hit regularly. In 2009, an amateur astronomer spotted a fresh impact scar. In 2010, another flash was caught on camera. Jupiter absorbs these blows for us. Some scientists have pushed back. More recent simulations suggest Jupiter also flings objects inward that would have otherwise missed us. Jupiter is both shield and threat, protector and executioner. But the deeper problem isn't individual asteroids. It's the systemic influence. Jupiter's gravity maintains the asteroid belt, millions of rocky bodies that never coalesced into a planet. Every time material began to clump together, Jupiter's perturbations shattered it apart. The asteroid belt isn't debris from a broken planet. It's a planet that was never allowed to be born. This extends to Jupiter's own moons. It has at least 95, and the 4 largest are worlds in their own right. But Jupiter treats them brutally. Io is the most volcanically active body in the solar system. The heat source isn't radioactive decay, it's Jupiter. The planet's gravity flexes Io's interior like a stress ball. This tidal heating melts rock from the inside. Io is being cooked alive by its own parent planet. Then there's Europa. Beneath its icy shell lies a global ocean, possibly containing more water than all of Earth's oceans combined. Jupiter's tidal forces keep it liquid. This makes Europa one of the most promising places to search for life. But Jupiter simultaneously bathes its surface in lethal radiation. An unshielded human there would receive a fatal dose within a single day. Protection and destruction, wrapped in the same gravitational embrace. So let's step back for a moment. Jupiter destroyed potential planets. Jupiter shields Earth from some impacts while redirecting others toward us. Jupiter prevents an asteroid belt from becoming a world. Jupiter tortures its own moons with tidal forces that melt rock and maintain hidden oceans. You might think that's the full picture. It isn't. Jupiter almost became a star. It's composed of hydrogen and helium, the same elements that fuel the Sun. If it had been roughly 75 to 80 times more massive, the pressure and temperature at its core would have been sufficient to ignite nuclear fusion. Our solar system would have been a binary star system. It missed that threshold by a lot in absolute terms. But the fact that it's even in the conversation tells you something about this planet. It sits in a strange middle ground. Too large to be just a planet, too small to be a star. A failed star. A gravitational tyrant. Jupiter emits nearly twice as much heat as it receives from the Sun. This excess comes from slow gravitational contraction, the Kelvin-Helmholtz mechanism. It's still shrinking, still generating heat from its own weight. A planet that is, in a real sense, still forming. And we're only now beginning to understand it. NASA's Juno spacecraft revealed a magnetic field far more complex than expected. Clouds extending thousands of kilometers deep, and a core that may not be solid at all, but a diffuse mixture of heavy elements. A fuzzy core. Nothing about Jupiter conforms to simple models. The Europa Clipper mission will take the next step, mapping Europa's ice shell and searching for the ingredients life would require. If biology exists beneath that ice, it would mean Jupiter, the planet that destroyed worlds, also created the conditions for life on its own doorstep. So, what does all of this mean for us? We live in a solar system shaped by violence. Jupiter carved the inner solar system into what it is today. It determined which planets survived and which were erased. It set the boundaries of the asteroid belt, sculpted the orbits of comets, and created the conditions on its moons that make them some of the most fascinating places we know. Earth exists in a narrow corridor of safety that Jupiter helped create, even as Jupiter remains capable of ending everything with a single redirected asteroid. The margin between protection and destruction is thinner than most people realize. And perhaps that's the most humbling part. We think of our solar system as stable, orderly, predictable. But the planet that dominates it is a churning, radiating, world-swallowing giant that spent its youth destroying planets and reshaping the orbits of everything it didn't consume. Jupiter isn't just a planet. It's the reason our solar system looks the way it does. And whether that makes it our greatest protector or our most patient threat depends entirely on the trajectory of the next object it decides to redirect. I hope you enjoyed the video. If you did, I'd appreciate your support. See you next time.